Hello. Hi. Good evening and welcome to this program for today. I'm going to be your instructor. First, I'm going to introduce myself and then we are going to kickstart today's program. If you have any questions, you can ask me. But before that, we are going to start with a quick introduction. So if you are in the chat, kindly drop a hi message. Let me know that you are online. So my name is Owusu Edusei Kofi, or Kofi Owusu Edusei, and I welcome you to today's session, Drone Data Clinic. First of all, I would like to introduce myself and what I do, who I am. So, I am the founder and CEO of SokoAerial Robotics. Let me know if you can hear me. So, as I said earlier on, I'm the founder and CEO of SokoAerial Robotics. I'm currently the director for the Center for Unmanned Aerial Vehicle Research, Development and Education, which is a joint partnership between the Ghana Armed Forces Signal Training School and Directorate of Communications. My educational background is in telecommunication engineering, communication technology engineering. I did my BSc in Ghana, as in Ghana Telecom University, my master's in Germany, University of Ulm, and I'm a certified unmanned autopilot systems expert from Aris, US. So with less ado, I will go to today's program and why we are having this training session. So basically, over the course of time, I have gotten a lot of requests from students, from our alumni who have been part of our training school, and over the course of time, they do come with a lot of issues that need to be addressed. And these issues will be taken care of in this presentation. So in our 1 hour to 2 hour session, we're going to look at how to prepare your system for data processing. We're also going to look at the kind of problems that is associated with image processing. So we're going to run through the entire image processing system. That is from the basics to the advanced system. And we're going to look at how to clean the data, generate the relevant mesh, as well as make sure that we can export the data to whatever platform that we intend to use the data for. Now, we are going to use Agisoft. And the data will be made available to the community. So the link will be posted afterwards, after the training, for you to download the primary data, for you to also have access to the data and practice. You can download Agisoft for free for a 30-day period. You may have a few limitations where you cannot do certain things that I'll be doing here. So this training is also to help you. When you get the full software, you can just go beyond what we're going to do today. Okay, so with less ado, I'm going to switch directly to the software, and then we will get started. So on your screens, we have our Agisoft software. Now, my data is data from a Galamsey site, where we're going to look at the impact of the Galamsey activity. And in here is my ground controls. But before we look at the data, let's set our system up so that we can optimize our process and make sure that we are using the right systems hardware to process our data. Agisoft is very heavy hardware dependent, and we need to make sure that we set out the right graphics parameters to make sure that we are processing the images without stressing the system. So let's first prepare our system. So what we're going to do next is to go to Properties. So we go to Tools, and on Tools, we go all the way to Properties, and we move our attention to the GPU. On this system, I have an external graphic card. So most of your systems, you need to check if you have an external graphic card. And once you have an external graphic card, kindly check this and also check what is down here to optimize your process and apply. Now, once that is done, the next thing for me to do is to bring in my images. So I will do that by bringing in my images. Now my images are here. I'm going to upload them. But before that, let me first create a chunk. So a chunk is created. Unfortunately, I have two, so I can just remove one. So I have a chunk here. And I'm going to now copy all my images into the chunk. So I'm going to copy all the images into the chunk. So I'm going to click and drag and drop it into the chunk. So I'm going to do that. Okay. So I have my images uploaded, and in the thumbnails here you can see all the images being uploaded. So the source drone was a DJI drone. So once I go to the info section, I will see the maker of the drone in here. Okay, now with that done, I will start working on my processes, okay? Now, this is a camera orientation of how my images looks like, okay? Now, once my images is uploaded, the next thing for me to do is to make sure that the image is in the right coordinates or the right frame. So I need to now convert my image. Now, once that is done, so just a second, let me just set my screen properly for the whole screen capture. So just give me just a second. I'm just getting the right display so that we can move pretty fast. Okay. Now, for me to set this reference plane, I will go to the reference panel, go to convert, which is like the calculator button here, and then I will go down to select the right coordinate system, which is WGS 84, UTM zone 30, and then I will click OK. So once I click OK, it is captured. Now, the next thing for me to do is to import my ground controls. And one of the key things that you need to align yourself with is that whenever you are importing your ground controls, make sure you are using the right coordinate system. So by clicking on now by clicking on the import button, we can bring up our ground controls. So we will just navigate to where our data is. So our data is stored in our drone data clinic exercise. And so this is our ground controls. We're going to import our ground controls. Just a second. Now, if you can see me on the screens, once we import our ground controls, we need to accept the new marker creation. So now you could see we have our ground controls imported into our data. Being captured into our data. So here we have our images, and at the very bottom here we have our ground control points here. Sorry for the delay, I just had a little glitch in my data, so I have fixed that. Now, what we would notice that this is the eastern coordinates as well as the northern coordinates of the data and the flight height. One will ask, why is the flight height so high? So basically, this is the relative height, which means that the terrain height has already been added to the flight height, and this is the accuracy of the drone. Now, this is my markers or my ground points, and these are the coordinates that comes with it. One of the tricks that you need to focus on is that the easting up here should match with the eastings on the markers. So if you flip and you bring northings here and you have eastings here, you will have some mistakes in terms of your alignment. And this is the ground elevations, as in our Z, and this is the accuracy of our point. Now, when I go back to my workspace, you will see that I have the camera here, which indicates the number of images against the number of markers that I have. Once I switch off the show camera, I get to see my images disappear. So in this case, I'm just going to leave it on so that I have my images and markers appearing. So, quick recap of the first session. We have uploaded our images, converted the coordinate system to match the coordinate systems of that of the ground control points. We have also imported the ground control points and make sure they align exactly where they're supposed to lie. The next step is for us to start the workflow. Now, the first stage in the workflow is image, or let's say align photos. So basically, we're going to align the images with respect to a reference pre-selection as well as a generic pre-selections. Now, when you look carefully into the software, we have different accuracy perspective. And it is a matter of your resource and the accuracy of the job that you're looking at. In most topographic applications, you're supposed to use medium to highest. And in less topographic applications like forestry and other related applications where accuracy is not of a big problem, you can do medium to lowest. Now, for the sake of this training and resources as well as time, we're going to go with the lowest to kind of have a very quick results and see what is happening. So I'm going to select lowest. Now the next thing for me to do is to select what we call the key point limit as well as the tie point. So now, what this means is that if you have two images which are taken at different instances by the drone. Now, what happened is that the drone image, which were taken at different intervals, tends to have similar features within these two images. And in order for we to stitch these two images together, we need to select points from image A and points from that of image B. And by so doing, we're telling the system that we want to set our tie point limit to 4,000. So we want to select similar points within these two images, but we are limiting it to 4,000. And we need key points out of this selection to about 40,000. Now, once that is done, and one thing you have to also understand here is that these figures are not just chosen randomly. Different application and different figures that we need to choose. So I'll also attach a reference guide in terms of how to go about these key point selections. So now that is done, the system is processing the images. So what you see here is the number of points being selected from the images. So you see photo 19,249 points have been selected, and the CPU, GPU is working tirelessly to generate this data. So this is our first online series. We hope to bring you more, and I apologize for the glitches in the system. It's the first time we are setting it up and trying it, and we would appreciate your comments in the comment section. So the system is still processing. Let's wait a little bit. Now, the system is estimating the camera location, as you can see on your screens. So whilst we wait, if you have any questions, you can send them ahead of time, and I will answer them during the So our data is ready. I'm going to off my camera. Now, interestingly, you will notice that there is a bounding box that is covering the image. Now, the next thing for us to do is to filter our markers and make sure. So let me just align my workspace. Let me bring my photo panel up. Okay, so my photo panel is just down here. Now, we need to make sure that our ground points are exactly on the markers. And what we need to do is to go through our markers, filter the images that have these markers on them. So here we have GCP9, and by clicking on GCP9 and going to filter photo by markers, we have images that happen to have GCP9 on them. So these are the images that have GCP9 on them. Now, we have to manually select these images and try to locate the GCP point. So on your screens, you can see your GCP point. You can see your GCP point here, but this is where the marker is. So the marker is a bit off. Now, when you do a measurement between this two, you see that the marker is about 8.4 or 8.44 meters off. And this is not good. So what we need to do is to make sure that we can correct this. So by so doing, I'm going to move my marker onto my GCP. Now, you notice that the moment the marker drops on the GCP, these green flags goes up. And this is an indication that we have done what we call the correct projection by bringing the marker onto the right GCP. So I will repeat this process for almost all these images that you find these markers in there. Now, we need to pay a critical attention to the error margins as well as the projections on our screens. So I'm going to go to the next image, and you see that by virtue of getting the right point correct, the rest starts falling in line, or the rest starts converging at the marker. So I will make sure I repeat all of this for all the images that have the GCP9 in it. In principle, you need at least more than 10 projections to help you with your ground truthing. So make sure you have very good number of images that have the markers falling on them, with your markers having that kind of indication. If you do not have very good visual on your marker, my advice is to focus on the ones that you have very good visuals on and ignore the ones that you don't have very good visuals on. The reason being that those ones with very poor vision will contribute to your pixel error, and pixel errors will lead to your errors in your final data. So if you are not sure of the marker point, just ignore it, don't touch it. So a typical example is this. So you can see there's a little bit of bending in here, but at least I'm sure that is the point. So I've selected 11. So let me go through the rest and then see if I can get some very good visual. So this is very good a bit. So I'm going to use this one too. And this one. Now the next thing I will do is I'm going to repeat the same process for marker 9B. So I'm also going to filter it as well. And then I'm going to align my marker to the GCP. Now this one, let me also measure the off distance. So I have about 4.94 meters off. So I need to make sure I correct that. So I'm going to drag my marker all the way onto my GCP. So I have this. First, my work process is that I will go through and look for the best ones that have very true prediction than the ones that I cannot see. So I'm going through randomly to make sure I select the best ones first. And once you get the best ones right, the others will converge to that point. So yeah. So this is a bit off. Let me just skip this one. Let me focus on other ones that. One big problem with data collection and GCPs is that most of the times pilots fail to make bigger GCPs, because the problem is that the higher you go, the smaller your GCP becomes on the ground. So if you know you're flying at a higher altitude, make sure your ground markings is very big enough. Second point is that make sure the spraying or whatever color you are using with your GCP has contrast with the terrain. So meaning it should be, your marker should be more visible or have a strong color compared to that of the ground. So in this case, the pilot used a white marker, but even though there's still a bit of challenge, but it's a bit visible. So that is one key thing that you need to do on the field to make sure you have very good data. So I'll keep going through to look for the best ones before I will go and work with the ones that are not that good, because once I get it right with the correct ones, they will really converge the rest. So I'm doing a repetition for all of that. So if today is your first time joining this program, I would recommend you subscribe to our channel and keep us updated in terms of what you want to know when it comes to drone technology, drone data processing, and we will make sure we bring you the best content to assist you. Yeah. So now I have about 15 images that I have touched on, so it's enough. The rest are not that visible, so I'm going to ignore them and then move to the next GCP. So I'm also going to do what we call filter photo by markers. So I'm going to work with GCP 10, and I've done the filtering, and the images are up there. Again, I will measure the offset. So from my GCP to my marker, it's about 6.38 meters off. Sorry about that. Now, we need to do this correction by bringing the marker or my GCP to my marker and make sure it's well aligned. So once you get it right, you see you get this green flag. And I will do it for the rest as well. So you could see automatically they are converging, but they are not really aligned properly. So I just need to give it a little bit of notch, and then I'm good to go. You see, it's converging very nice. So yeah, it looks like this marker is very visible. So almost all the points are really converging very nicely. Yeah. So I'm going to repeat it for the rest. So we're doing a very detailed training. We're going to go through it. So make sure that we understand the principle. I'm going to move to the next GCP. So that's GCP A. And I'm going to filter the photo by markers. So I have done that as well. So you could see that this is also off by, let's check out by how many meters, which is always a good reference. So it's about off 3.6 meters. So we need to correct that. So we push the marker onto, or the point onto the marker, and let's hope. So you see it's converging. You see it's getting closer. And let me check the distance. So that's about 80.5 centimeters. So we're getting there. Let me correct it. Yeah, so now you can see the rest are converging. This is on the edge. I need to get it into the center. Always focus on the center, because the center is where the surveyor picked the coordinates. So don't put it here, 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 or here. Just focus on the center. Sorry about that. So can everybody hear me? If the audio is good, kindly drop it in the comment. So let's continue. I hope you guys can hear me. So I'm going to repeat it for all the images. Yes, Leonardo, yes. If it was 1,000 images, you can automate it. So mostly with GCPs, you cannot you cannot automate it. You mostly have to do it by yourself. And as I said, the number of projections should be above 10. Once you have 10 photos that are well aligned in the image, is good enough. So, but you can automate your image alignment, automate the rest of the processes, but it is always hard to automate the GCP alignment. So, yes. Thanks for the question, Leonardo. I really appreciate it. So I'm going to do that. But the beauty with this system is that once I'm done with the alignment, I'm going to show you one trick that we use to improve the prediction as well as improve the marker points. And that is we optimizing our marker to the GCP. So I'm going to do a quick measurement of the offset, which is from the GCP to the marker. This is about 8.5 meters off. So we need to correct that. So I'm going to drag this all the way onto it. And then do the same for the rest. So you can see it's converging very well. Now, one of the issues with low or entry-level drones when it comes to photogrammetry is that these drones do not have centimeter level accuracy in terms of GPS. So mostly you have a meter level accuracy, which is about 3 to 5 to 10 meters. And especially you get this with DJI drones a lot. And in using these drones, in certain applications, the level of error is acceptable. But if you're looking at using your drone data for topographic applications, centimeter level accuracy is what is required. So when you look at the error here, so for example, this is the accuracy that comes with the images, which is onboard the drones. And this is the accuracy that comes with the RTK GPS that was used to pick the ground points. And these are the projections in terms of what I have selected, or that I'm sure that the marker is in the images with respect to the GCP. And this is my error in terms of pixels and my error translation in terms of meters, averagely. So you remember you saw me doing measurements. And so this is the average distance error that I need to correct against this one. So what I'm going to do next is to optimize my system so that I reduce my error to a centimeter level. Okay. Now, for me to do this, the next thing is to go to the optimize camera environment. Now, with the optimized camera environment, I'm going to correct my focal length. So the first thing is to correct my focal length, fit my CXCY, my fit K1, K2. So I'm going to fix all these projections. And then also make sure that I adapt my camera model to fit my convergence points. So you remember the marker was at a certain point, and then my GCP was at a certain point, and I dragged my GCP to fit my marker. Now the next thing for me to do is that within that space that I have dragged my GCP to my marker, I need to increase my accuracy in terms of my estimation of my convergence point. So that will lead me to check these two boxes. And let's take note in terms of these errors that we are getting here. So I'm going to run this process to optimize my camera correction as well as my GCPs. And now you can see that is done, and you can see that my error has completely dropped heavily. And this is so good. This is that's dropped completely to a centimeter level. So now what I'm going to do next is to save my work and then continue. So I'm going to save it. Data processing, session 1. So that is done. Now, interestingly, we had all the images aligned. So if we had any issues with our images, we would have had some images rejected by the system, and that wouldn't have run well with our system. So the next thing we're going to do, now our system has optimized our GCPs. We are getting a centimeter level of accuracy, which is very, very good. The next thing for us to do is to build our dense cloud. Again, the general quality, as I said earlier on, for topographic applications, it is always medium to highest. But due to resource constraint on the system that I'm using, and at the same time the timing, we're going to go with low parameters to process the data fast so that you can comprehend the entire training. So when you click down here, you have ultra high, high, medium, low, and lowest. And also, so always make sure when you're doing topographic services, you do medium to the highest. Medium to low will not really help you with your accuracy. The next is the the mode of depth filtering. So here you have so many sparse or so many uncorrelated points created out of image. Now, what we need to do is that we need to calculate the point colors based on a particular depth filtering. And we have a mild, moderate, and aggressive. So what I'm going to do is that depending on the same thing in terms of your resource, the system, you have to know which filtering algorithm to go with. Mostly goes with aggressive. So let's look at the results of aggressive. It's going to take a little bit of time, and we will see the end results. So I'm using an OpenCL Intel graphics to help accelerate the processes. So we are waiting for our data. I didn't select so much images, so I'm sure it should be done in no time. So you can keep your questions coming in. We have some members of the training program in the group. They will be answering some of your questions. So Jerry D is there. Angela Tiva is also there to answer some of your questions, whilst I will also answer some here whilst the data is being processed. So please subscribe to the channel. Please let's have your comments so that we can keep improving on our trainings and make sure we give you the best online trainings as well as webinars. So we are processing or trying to generate the depth map. So I think in our next training session, we will look at automated batch processing. So the team has taken notes, so we will also do that as well. So our data should be ready in no time. The estimated time is about 10 minutes for it to be ready. So we've gone through the sorting of the point clouds. It has done the process matching. It's selected all the images, done 20 by 20 selection, and this is the resource allocated that is using. So we should be getting our results in no time. And the rectification is being done on the images. So a very interesting question by Foster. So the machine specs that you will need, mostly the manufacturer comes with its recommendations, and these recommendations are based on the manufacturer's statistics based on the software's resource demand. So I would say that you should first focus on your graphic card, second your processor, and then two your hard disk space and your hard disk technology. Now, when it comes to the graphic card, I will recommend an NVIDIA graphic card. Anything above 6 gig is relatively good for a start. And then for the CPU, I will recommend between 4 to 8 cores, Intel or AMD, 2.0 plus gigahertz. And for the RAM, I will say 16 to 32 gig is good. For the external graphic card or the GPU, NVIDIA is good, AMD is good, but anything above 700 plus CUBA core would really help. The system that we are using is currently using the G4 GTX 102080. That is like the basic configuration. So for a beginner, you can look at that. If you are looking at an advanced configuration, you can build your system up to 120 gig per RAM, where you have about your CPU, you can do 6 to 24 core Intel or AMD, and your speed should be about 3.0 gigahertz, and your RAM should be about 32 gig to 128 gig. And when you're looking at your GPU, I would recommend the GeForce RTX 2080 Ti or Iridium 4. So currently at the lab or our center, we have one of the advanced system and two of the basic configurations. And one of the things that we do for clients is that we process heavy duty data for clients who do not have the resources to have this infrastructure in the organization. So we do offer these commercial services to clients. So it's a very simple process. We have a cloud platform where you can upload your data, and then we process the data for you, and you will just submit your data back onto the cloud platform for you to have access to it. If you don't have internet connectivity at your location, what you can do is to just send the data via a courier, and once the data is ready, we'll send it back via a courier. So, Foster, I hope I've answered your question. So whilst we are still waiting, we can. So we have about 5 minutes to go. So any further questions whilst we are waiting for the system to finish processing the data? Thank you, Bilal, for subscribing to our channel. We really appreciate it. Thank you so much for the subscription. So, yeah, we will. I think the reason for doing this is to make sure I take you through the entire process, because a lot of our students keep asking this question. So let's bear with the processing so that we will actually see the workload in terms of the system resources. Let me pull up my So you can see here how the system is really eating up my resources. Yeah, my CPU is crying. Likewise, my hard disks, it's okay. My memory, yeah, it's okay, but the CPU is really peaking. Yeah. So let's enjoy the process. And if you have any questions, please drop them in the comment section. And don't forget to subscribe to our YouTube channel. And to all the viewers, I will say I appreciate your time. I appreciate your effort in terms of putting your data to a very good use. We are having a drone piloting and training program come next month. The numbers are running on your screens, and if you want to participate in this training, just call us, or you can, even before the training, you can pay us a visit at the facility to look at what we have at the facility and get a test flight on some of our drones so that you could really appreciate what we are doing here. So we are about 49% done. So yeah, we should be done in no time. So in the comment section, I can see W01 Adade, thank you for joining us. Foster, thank you for joining us. Ijabin Samuel, thank you for joining us. Summertime, thank you for joining us. Leonardo, thank you for joining us. Pascalina, thank you, really appreciate your time. And our own accent is also here. Thank you for joining us. So we are almost 55% done. As I told you, the larger the number of images, you should make sure you have a better resource to process your system very fast. I'm using my laptop. I'm not using any of the server room systems. And as I said, our current infrastructure can process about 3,000 images in a day. So if you have any huge data that you want to process, just shoot us an email and we can help you process this data in a very short time. Don't burden yourself with all these headache. We want to take the headache on. So we are about 66% done. We should be seeing some interesting results in no time. Okay, so now we are done with the first phase. The dense cloud have been generated. It's going to start sure that we get the best points to generate the dense cloud. So I'm going to attach a link into the comment section for those of you looking to build your own systems or looking to understand the system requirement for Agisoft. You can look at that. So, and I'm also going to attach a download link to so whatever platform you have, whether Linux or Mac, you can download a trial version and then practice. The sample data will be uploaded to Google Drive and it will be attached to the link. So when you are ready and you want to try your hands on it, you can easily try your hands on it. And if you happen to have any challenge, just let me know, drop it in the comment section and I will gladly help you. Yeah, great. So our data is ready. Now I will move to the workspace. So just a quick transition here. So now I'm at the workspace, my data is ready. But the next thing I have to do is to visualize my data, but let's pay attention to some very interesting detail here. So you could see after the tie points, we have what we call the depth map. So 100 images, the quality, I told you the reason why we chose the quality, and then the filtering algorithm that was used. And in total, we have generated about 535,000 points from the images. But you could see here, you cannot really visualize these points clearly. So we're going to enable that visualization for us to see the impact of this next process. So we double click on the dense cloud, and by so doing, you could see how rich our data looks like. Interestingly, this is where the Galamsey activities was happening, in the middle of the forest somewhere. So that is our data in there. So you could also see where our GCPs are in terms of the terrain. And I will say that it's not an easy terrain to access. So our pilots and data team did very well on the field. They had to create access, they had to weed and create paths, and then make sure that they have clear vertical spaces to place the markers on the ground, and at the same time the drone should be able to picture this data. So once this is done, you just have to save the data. So after every stage, you save the data. And in the next session, we'll be looking at batch processes, or in our next training program, we will look at batch processes. So now once we are done with the dense cloud, the next thing we need to do is to classify our ground from the vegetation. Because as I said earlier on, we are trying to generate the topo data for the terrain. And for us to do this, we need to separate the ground from the vegetation. So what I'm going to do is to do this process. Now, first, what I need to do is to go to my dense cloud and then go to classify ground points. So I'm going to classify the ground points. Now, you could see that we've not done any classification on these data yet. So it's a fresh classification. So we go by created but never classified. Now, before we do that, let's look at some interesting details here. So you see the data is still raw, as in there is no classes, there is no filtering. So you cannot really distinguish between what is ground and what is the vegetation. So we now have to do that by going to the dense cloud and then go to classify the point. So let's do that. So created, never classified, and then we are classifying ground points as well as the low point. We're going to leave the maximum angle at the default value, the maximum distance also at the default value, and we're also going to leave the cell size at the default value, and then we're going to run the classification. So the classification is done. Now you could see we have some interesting display here, right? Now on these screens we have about 3 different colors. We have the white, we have the brown, and then we have some pinkish information here. Now the pinkish is the low points or the noise in there. The brown is the ground, and then the white is the high vegetation that we have in there. Now the next thing we need to do is to filter these points out, so that, we don't need the high vegetations. So once we don't need that, we go to dense cloud, and then we go to filter by class. Filter by class. So we click on filter by class, and all that we need is to uncheck the points that we don't need. We uncheck the ones that we do not need, and we leave the ones that we need. So we're going to uncheck all these information, and then keep the one that will help generate our topo for us. So we're going to remove all of that. So we are left with only ground, and then we click OK. So you could see this is a beautiful ground data, very beautiful, with our points on it, and it's really depicting our terrain. Now once this is done, you have to save each step. It's very important, because so that you don't lose your data in case of any power interruption or system interruption. You have your ground information. Interestingly, you have some holes. So those holes as a result of the filtering that we have done, or as a result of we separating the ground from the vegetation. So that is that. Now the next thing we need to do is to seal these holes. And one will ask, why do we need to seal these holes? We need to seal these holes to help us with making sure that when we are interpolating our contours, we get a smooth interval generation. So in order for we to seal these holes here, we need to build the mesh. So the next workflow is that we go to the mesh and then we generate the mesh. Now, as I said, we're going to use a very low count based on due to time and resource. And we're going to use we're not going to use a 3D spot height, we're going to use a 2.5D spot height. We're using the sparse, that is the filtered information. And we're going to keep it at the default. So we're going to now select this and process the mesh. So you could see beautifully, let me just show the wireframe. So that is the wireframe of the entire mesh, right? That is the wireframe of the entire mesh. Now let me also show you the shade. So you could see now the holes have been filled very nicely by the mesh build. In most situations, or sometimes you may build your mesh, but you may still end up with holes. So especially when you fly over water, or when you fly over water or reflective surfaces, it's very difficult for you to close it. And what you do is that you go to mesh, and then you go and close these holes, or you go and smoothen the mesh in order to close these holes. So the good thing with our data is that we didn't have that problem because the data was not having any reflective surfaces. So whenever you have a reflective surface and you have holes that cannot be closed after you've done your mesh process, the other option that you have is to go to the tools button under the mesh and then go to close holes, and then that will close the holes for you. So now our mesh is built, the next thing we have to do is to, but as I said, it depends on the application. In this particular session, we are focused on generating our digital elevation model or digital surface model. So we're going to skip building texture and tile models and go directly to a DEM generation. So in the next session, we may look at these texture and tile model build. Now we select our DEM and we need to tell the system. So first of all, the projection that we are using is in the geographical coordinate system. So we are in WGS 84 UTM zone 30. Our source data is the dense cloud. So we're going to go with the dense cloud. And the interpolation that we are using interpolation. Now, if I go to mesh, what happened now is that my point classes my point classes are not selected. So mostly we don't use mesh to build our DEM. So we will stick to our dense cloud, and then I will go here and take out the unwanted points from my ground data in order to generate my ground point. So I'm going to uncheck these two from the system and then continue with my process. I will leave the rest as it is, and then I'll click on run. Beautifully. So our DEM has been generated. So, I mean, this is beautiful. You could really see the terrain model, the terrain change in terms of the relevant height displacement. And you can see here the hole has been filled very nicely. And all these edges as well, it has been filled nicely. And these holes are also being filled nicely. So just inspecting our data. And the next thing we need to do is to just click on the save button and move to the next stage to build our auto photo or auto mosaic. So I click on that. Now, we still keep our data in the geographical plane or geographical coordinate system, WGS 84 UTM zone 30. We are using the DEM, which is the surface input data, to generate our mosaic. And the algorithm that we are using the blending algorithm. So it's kind of like blends the image whereby you don't see the individual images that have been taken. So that is what we are using. So we are using so when you come here, we have a lot here. So we are using the mosaic blend mode. We're also going to enable hole filling. So in case there is any holes that couldn't be closed, at our final processing, we are telling the system to close the holes. And then afterwards, we're just going to run the system to generate our mosaic for us. So whilst we wait for our mosaic to run, you can please drop your questions in terms of what you've learned so far and what you would want us to discuss in this session. So the floor is yours. I'm waiting for your questions. Jerry and Angela will also be assisting. So yes, we are building you could see the processes. So it's generating the auto mosaic, it's analyzing the DEM, it's estimating the boundaries, and making sure the right number of cameras are selected. So in this case, we did not have any wrong image, which could be an oblique image or could be an image which had a different perspective to the rest of the images. And when that happened, that image has to be taken out of the rest so that we can have a proper rectification of the images. So now we are stitching these images in one big mosaic. So far you could see that 20 images has been rectified, and we'll be doing the next 20 image rectification. So we are still coming to the latter part of the processing before we will have a final look on our data. So we are waiting for our data to wrap up. We're about 9% through. So those of you who are interested in joining our, you can call the numbers on your screens. So we are still waiting, and once our results, so we are about 13 minutes into our data. It's all about resource. It's all about resource. So you could see the data is running through the different mosaic being generated. So this is like image 105 being used to give us this export. So whilst we are waiting, kindly post your questions on the forum or in the comment section, and then I will assist you. If you are looking for sample data to also try your hands on, I'm going to attach a link where you can have access to some of the data for you to try your hands on. So far, all the steps that we have covered, I'm going to put that in the comment section. For you to tag along. So first we loaded the images. Align the images. So we loaded the images into the software, aligned the photos, imported the GCPs, optimized the marker cameras, generated the dense cloud, filter the ground points, and then use the ground point information to build our DEM. And then now, with that information, we are now about to build our automosaic. So our data is almost getting ready. Yeah, so our data is finally ready. This looks very interesting. Now, once the data is ready, the next thing we need to do is what we call quality control. So what that means is that we need to make sure our markers are exactly at where they are supposed to be with respect to our GCP points. So a typical example is, I will zoom in on marker 10 and make sure that is correct. So this is this information is there. So I'm good with marker 10. I'm going to check the other ones. So yeah, this is very good. This is very, very good. It's exactly in the center. And then check this one too. It's a little bit off, but as I said, it's always good to do the quality control. Yeah, this is good. Let me check this one too. Yeah, so this is, so let me just do the measurement and check the, yeah, this is about 18 centimeters off, which is okay. Can work with that. Let me check the other one at the top. So it's 18 centimeters off. This one is so this one is here. So this is having about 1 meter off. So this is why you always have to do quality control. So ideally all the markers are supposed to lie exactly on it. So if you're having these issues, you need to realign your GCPs on your markers. So you'll have to go back and do the whole process again because you had 2 points wrong. But interestingly, we have about, so point 10 is correct. Point A is correct. 9B is correct. So yeah, just a little off with GCP 9 and then GCP D. So as I said, accuracy will be based on the application you intend to use it for. Now, the next thing we need to do is to export our data, and the big question has always been that what is the best way to export your data in such a way that you can get the best output to process or to work with. Now, what we're going to do is to first export our AutoMosaic. And when you go down to the export button, we're going to do about 2 or 3 different type of exports. So first we're going to export a GeoTIFF file. Now, once you come to the export button, interestingly, you still see that your coordinate system is working well, it's correct. You have your pixel sizes indication here. And you have what we call the max dimension pixel or split blocks. Now, most of the problems that comes with large data processing is that sometimes you have a huge number of images that after processing, you'll be ready to export the data. But then what happened was that the system would tell you the exporting data is too large. Now, most of the time, it is never from your system. It is a limitation from the software. So Agisoft technically has a limitation where it cannot export anything above 4 gig. So when this happens, you need to split the image into blocks and then export it. Now, when the image is not that huge, you can go straight and then you can export it. So in this case, we're going to look at 2 exports. We're going to split the image and then export it. So I'm just going to change the dimension. So I'm going to change the dimensions and then we're going to export that. And also you can choose which background that you want, whether it's white or black. So let's go with white so that it will be easy to use GIS to visualize our final output. So I'm going to do the first type of export where we are splitting the images into blocks because of the size. System is kind of having an error exporting the image due to the size and the system poses. So I'm going to create a folder called export, and I'm going to, so I've named the image B5. So we are exporting so you could see on your screens here, our export image is coming up. So we have 1, 2, 3, 4 images coming up. So our images have just been exported. Now I'm going to come up. So always make sure you save your data, and then bring our visualization tool. So we're going to use QGIS to visualize our data. So this is, I'm using QGIS to a free geospatial software that you can use. So I'm going to select my image, I'm going to drag and then drop it onto the, so what you can see here is that the 3 individual images have beautifully assembled. So you can on and off. So you could see, so like these are 3 separate images put together. So this is the first image. This is the first image. So this one. And then you have the second image. So this is the second one here. And then you have the third block, which is the entire image here. Okay, but it is mainly due to the dimensions that I chose. I didn't want to end up with so many blocks, so I kind of increased the block size to about 11,000 by 11,000. So this is how my final composite image is looking like. In our subsequent clinic services, we will be showing you how you can merge all these data into one composite image, as well as compress this image of export. So I'm going to minimize this, and I'm going to delete everything here, and then go back to our processing software. So let's look at our second type of export. So I'm going to go back to QGIS. Now this time around, I'm not going to check the splits blocks. I'm just going to run it. So I need a single composite image. So I'm going to do that. So I'm just going to click on the export, and then it will come up for me to save it. So I will create, I'm going to give it a name. I will create, just say B2 underscore complete. So complete one image, yeah. So I'm going to export that. So our data is processing beautifully. Okay, brilliant. So our data is ready. I'm going to minimize the Agisoft and then check on our single composite image. So this time around we have one huge one, so you can see it's just a single image. Yeah, so that is how you solve this problem when it comes to exporting huge images and exporting non-huge images. So in our next session, we will be looking at how to compress these images, how to manipulate them. So this 450 megabytes. I mean, it's very huge. So how can we compress this image without losing any quality? So we will be looking at that in our next session. Now, our next export is our DEM. So you could, all we need to do is to, but before that, a question just came in. How do we export this for Google Earth? So when you click here and you click to export auto mosaic, and you go to Google KMZ export. Google KMZ export. With Google KMZ export, you can export it for visualization on Google. So we're going to also try that. So Google KMZ export this as well. So let me save it as, let me just create a folder so that it will be a bit organized. Google data. So B5 underscore Google map. So that data will be exported. Now, once that data is exported, we can actually visualize it on Google Earth. And what this does is that it can help us check in terms of environmental changes, as well as check the accuracy of our data. And what you also need to understand is that Google Earth is always some years old, and it doesn't really depict the true terrain or the true data that is on the ground. Open my data for you to have a look. So this is my Google data. So I'm just going from Google to, and then open it. So that is the data here. So I'm going to open it. So it's going directly to where the data was captured. So you could see this is where the data was captured, which is very beautiful. I mean, you could see the activities that are happening there.